Guys, welcome to Cafe Simplified. Yes, and as we embark on this transformative journey, whether we work with unwavering zeal, determination, and focus, let's work together. Yeah, and always remember to share, like, and subscribe. We are diving into our statistics, and we'll start with these questions which we're left with. Yes. And I'd advise that at least a day somebody does at least a number of stats. Looks easy, but kinda gets tricky. 40 randomly selected students were asked the number of pairs of sneakers they owned. Let X equals to the number of sneakers they owned. The results are as follows. Then we are told find the sample mean, standard deviation, histogram. Yes. So how do we go about that? Something we need to note about this data is that we need to find out always at the back of our mind. We should be knowing whether the type of data is grouped or ungrouped. Yes, that is very imperative. So now when we look at this data, is it grouped or ungrouped? And what does it mean for data to be grouped or ungrouped? Grouped data is one which has been arranged according to intervals like 1 to 4, 5 to 8, like that. But when you look at this is ungrouped. Yes. So I think that is the brief explanation for that. Why is that important? It is essential to know that the formulas for grouped and ungrouped data differ. Yes, you might get roughly the same answers, but if you apply the wrong formula, it will definitely lead to the wrong answer. Yes, for example, here, when we want mean for ungrouped data, mean equals to summation of fx out of summation of f. Yeah. However, there are situations where you find they have given you lots of numbers like here. Yeah. These numbers have no frequencies. And if you have to find the mean, you will not apply this, but you will use mean, yeah, equals to summation of the x values out of n representing how many are they all together. Yeah, so that is very essential to note. So now here we will have 1 times 2 plus 2 times 5 plus 3 times 8 plus 4 times 12 plus 5 times 12 plus 7 times 12, and we get our x bar, which is the mean, equals to, we have 2 plus 10 plus 24 plus 48 plus 60 plus 7 plus 60 plus 7. Okay, hope you guys are getting the same stuff. Then we divide by their total f, which is 40, making our mean to be 3.775. Okay, so we come to that. They say find the standard deviation. Now, finding standard deviation for ungrouped data, we should find out our x minus in the table. In addition to this table, I'll create another column. I'll call it x minus x bar. Remember, this is our x bar for the mean. Okay, so we have x minus x bar. Then this group, this squared x minus x bar squared x bar squared. Then another column added should be f times this, the whole of it. F times x minus x bar that's squared. So you can complete this table, adding it to this. These values here represent the x values, the ones you're seeing here. What does that mean? It means here we have 1 minus 3.775, and we get our answer here. The first one being negative 2.775. So you are required to complete this table. 7 into 7. I'll just read for you the values here I've got down. The next one is negative 1.775, then negative 0.775, then 0.225, then 1.225, then lastly is 3.225. Then when we square those numbers, we are going to get only positive values here. And my first one here is 7.702. So square those numbers and see what you get. And the last one here is 10.403. So now we are having this field, multiply it with the frequency this side. The values here, multiplied with the frequency here. And here, the first one I have is 15.40404. And then the last one here is, last one will be 10.404. 10.404. So after finding that, we come to the formula. The formula for this, since you should remember that it is ungrouped. Ungrouped has a standard deviation formula, which is given by standard deviation equals to, remember standard deviation is the square root of variance, and the variance for this is summation of f into the x minus x bar squared out of, now since it is ungrouped, we get f minus 1. That one accounts for the fact that we are not starting from 0, but we are starting from 1. Yeah, that is something we have to note. So here it is f minus 1. Somebody might ask, why didn't we apply it on mean? It doesn't apply to mean. It doesn't apply to mean. But here when we are finding standard deviation, we put it there. So we get square root of 64.994994 out of 99. I think still that takes us back to the emphasis I stressed about, that grouped data and ungrouped data will always differ in formulas. So we land on 2.29 as our standard deviation. Then they're telling us to construct a histogram for the above data, and we are also required to fill in the columns. So when we come to filling in the columns, we want us to fill here relative frequency. What is relative frequency? Relative frequency is when we get the frequency f divided by the total frequency, which is 40. That means that we have 2 divided by 40, get the answer here, which is 0.05. 5 divided by 40, 0.125. 8 divided by 40, which is 0.2. 12 divided by 40, 0.3. 12 divided by 40, 0.3. 12 divided by 1 divided by 40, which is 0.025. So, believe we know what cumulative frequency means. If the first one here was, the first one was 0.05. 0.05. So you bring that number even here, 0.05. Now cumulative means keeps on piling, adding. So now the next figure here is when you get 0.05 plus this, then you get this. The next answer here is when you get this value here, you got plus the one which is here, you get what is here. Like that, till you reach the final one. And my last one is exactly 1. That is our last one. That is how we find cumulative frequency. Keeps on piling. Then they are telling us to find the quartiles. So just like I said, since this data is ungrouped, the quartiles also differ. We are used to this quartile of quartile equals to n out of 4, right? Or like 1 out of 4 times n, that is the quartile we are used to. But now, since it is ungrouped data, the quartile RQ1 slightly differs. So RQ1 is defined by n, which we know, now plus 1 to account for the 1 for interval, which we always don't start with, then out of 4. So this is our formula, and we have 40 plus 1 out of what? Out of 4. And our answer gives us 10.25. 10.25. So that means the 10th value or 11th value, which will be a 3. How do I determine that, or how do we determine that? You can use frequency and you know where does the 11th value or 20th value lie. So that means the first one is 2 plus 5, 7. 7 plus 8, 15. So it lies in between this, and we always consider with the highest, which is 3, which is 8, but corresponding to the x value, which is 3. I think we are clear to that. Then we come to median. However, when you apply the other formula, you might find that you're allowing the same answer, but as we said, let's always use the right method, especially to distinguish between grouped and ungrouped data. So when we come to mean, it's still the same story. That mean, because since it is ungrouped n plus 1 out of what? Out of 2. So that will be 41 divided by 2, and we get 20.5. 20.5. Does that mean? That means the 20th and 21st values. The 20th and 21st are the median. Yeah. So when we add this plus this, here 15 plus what? Plus now 12, that is 27. So it falls in between this and this, making our x value to be 4. Because we are not looking at frequencies, but the value is here. Then they are telling us to find the first quartile, third quartile, and the median. We found the median, then the third quartile is also given by 3 out of 4. Yeah, third quartile is this Q3. And this information is very vital for drawing a box plot, because without it we cannot achieve it. So 3 out of 4 into n plus 1, n plus 1, making us to learn to 3 out of 4 times 41, and ultimately our answer is the 30.75. It means the 30th or 31st values, and that corresponds to the x value giving us 5. Yes. So now they're telling us to construct a box plot for the above data. What are the prerequisites for constructing a box plot? The prerequisites are, we need to find out what is the mean, then establish the max, acquaint yourself with figures of the median, and the mean. However, sometimes if they have not asked the mean, you don't include it there. But it is also important for us to know where all these go. Yes. So we are left with 1, 2. That is the Q1 and Q3. This is all that we need to construct the box plot. So the minimum value is the x value which we are having. The minimum value is this. The minimum value is the minimum value which is in this x figures, which is 1. Then the maximum value is 7. The maximum value is 7. The maximum value is 7. Our median, we've got median as 4 here. Our median is 4. Our mean was 3.775. Hope we all recall that. Then our Q1, established our Q1 as 3, and finally our Q3 was 5. So actually the gist of making this tutorial was to demonstrate how to illustrate the box plot. Right, because we're wondering what's the box plot, how do you construct a box plot, and here comes Cafera Simplify, telling you that this stuff is ultimately easy. Here we are going to have, however, sometimes there is no basis of putting x and y. Like you can change the values here. I'm going to put here, and come this side, and you construct it horizontally. However, I prefer when it is vertical. Maybe if the lecturer highlights on it and gives us his preference, then we can stick to that. Yeah, so this is what is going on the vertical axis. We have 1 to 7, so I can start from 0. Okay, then do 2, then we do 4, then we do 6, then we go to 8. Hope you are very keen. You've noticed the scale. Then you can name this as our x. Then you put here. Whereas C1 is indicated here. So we come to this. Start with the mean and max. Mean is 1, max is 7. Mean is 1, 1 is here like this. So we can put something like that. Max is 7, max is 7, something like that. Max is 7, something like that. Then we come to our Q1 and Q3. Q1 is 3, Q3 is 5. 3 is here, and then 5 lies below 6. Yeah, so we draw our box plot, then connect the endpoints and the endpoints. What are the facts that we need to note about this box plot? Here we can put 1, see most times they put 1 figure. We need to know that this space up here or down, they share 50%, and the space inside the rectangle as well shares 50%. So if we have probably here 25%, this side also 25%, then the 50 is shared here, implying that the whole surface here to area of the box plot should be 100%. So we are having our Q1 here. You can indicate that Q1 here was 3, then Q3 was 5, Q3 was what? Was 5. Then we come to mean and median. Mean is always that line which is straight and solid. Emphasis is on solid, while, and obviously it has to be straight, while the median is that line which is straight and dotted. So our mean was 4, so we come to 4, draw a solid line. Then our median was 3.77, and for it has to be dotted. Yes, wow, we have, you can write them here if you want, but maintain the neatness and since it is small. Hope we've all got that. That's our box plot. They are telling us what percentage of the students owned at least 5 pairs come to our data. At least 5 pairs is 12 and 1. So that means the percentage of the students who owned at least 5 pairs is 12 plus 1 out of the whole total times the 100%. We are getting 12 plus 1 times 100%. It means we have 13 divided by 40 times 100. We get 32.5. We get 32.5%. Yes. So then they are telling us to find these other percentiles, the 90th and the 90th and 40th percentiles. So, like we said, we have to know what is the meaning of percentiles and percentiles. Percentile means like in 100. Yeah. Percentile means in 100. And so we will have, and since this data is ungrouped, I'm wondering if the formula changes. Yeah. To accommodate for the ungrouped data. I didn't indicate it. I didn't indicate it here in my work, but maybe it is something I'm going to ask you to as well excavate and find out whether we add the 1 or we do not add the 1. I didn't write that, but we'll have 48%. That means 40 out of percentile is 100. So times our total here, which is 40, and get the answer for that. Also, let's see, we have 40 divided by 100 times 40. We get 16. Then here, so after getting the 16, that is in position, you come find out 16 falls in between where this and this is 15. So for 48 percentile be corresponding to 4, because we are interested in the x values. Then you come to the 98th percentile. 98th percentile will get 90 out of 100 times the total. And my task here was, do we multiply with 40 or 41? Yeah, put that in the comment section and I will be very glad to read your views. But here we get 40 and we get 90 divided by 100 times 40, get 36. So find out where does 36 lie here. And when we add this and this, which is x equals to 5. we are instructed to construct a line graph and construct a stem plot of the data. Line graph, I believe you guys are very confident with the line graph. I'm just going to give a simple sketch. Yeah, but this was not really the gist of the matter. Line graph will have the x values here, go here, from 0 here 0, 1, 2, 3, 4, 5, 6, and 7. And then here we'll have the frequency right from 0 to 4 up to probably 12. Always find a good sketch. Then we do something like that. So you join these things using your free hand and a straight line. And that is how something will look like. Yeah, I'm using a mouse on a computer, so do something very accurate. Then we come to stem plot of the data. We use this x and f to determine our stem plot. So we have here stem and the leaf. We have 1, 2, 3, 4, 5. We actually don't have a 6, but you indicate there 6 because they have to be in chronological order. Then finally a 7. I hope you noted that down, that we indicated the 6 even when it is not appearing anywhere. So for consistency, yeah. So this implies that the frequency is going to determine how many times we write the 1. So it means 2 1s, then 5 2s, like that. And so on, up, down, up, down. That means the last one we are going to have 1 7. Yes, that is our stem plot of the data. Thank you for following this far. Share, like, and subscribe. Bye. We'll meet for number 2.